Hello everyone. So today we are going to be talking about power in electric circuits. So essentially power is how fast energy is being used up, right? It's joules per second or watts. So power in an electric circuit or across a component, power is equal to the voltage across the component times the current through the component. And you can kind of see why this works by looking at the units here. So the units of voltage, that's joules per coulomb or a volt. The units of current is an amp or a coulomb per second. So you multiply those two together, the coulombs cancel, and you get joules per second, or how fast energy is being expended. So that's how you calculate power. Now, the question then that you might ask, though, is how do you know whether the component is consuming power or is it generating this power? And that depends on the orientation of the current. So let's go ahead and say we have a component here. I'm not drawing the rest of the circuit, but we're just fixating here on this component, and we don't know what it is, but we know that there's an electric current, I, flowing through here, and there is a voltage across the component, V. And let's assume that our variables V and I here, that they are greater than 0, they're positive. The question then is this component, is it consuming power? So when we multiply the voltage times the current, is it consuming that amount of watts, or is it generating that amount of watts? So let's think about this. This right here, the positive sign, that's like the upper tank, right? The minus sign is like the lower tank in our water analogy. And here we have current that is flowing from the upper tank to the lower tank. So going back to our water analogy, if we have an upper tank and water is flowing down and then flowing through like a water wheel or something, and then down into the lower tank, energy, as that current's flowing through that component, energy is being used up, right? It's falling, right? It's releasing that stored potential energy. So in this case, this component would be passive. It would be consuming power. But think about what would how that would be different if you had, again, a component you don't know what it is, but you do know there's a voltage V across it, and you know that there's a current I that's flowing this direction. And again, assume that V is positive and I is, our variable I is positive as well. So these are, you've got current flowing up here, and you've got the voltage in this orientation. And the question is it consuming power or is it producing power? Well, so basically the way we've drawn this, here we have current, we have electrical charges, or we have water in our water analogy, going from the lower tank to the upper tank. So now energy is it's being pumped up. It's being pumped up. So what's actually doing is you're actually adding energy to the the circuit, right? This is a case where it's the opposite of consuming power. You're actually adding power. So this would be like a battery, or it would be active. So that's how you can tell whether a component is, or that's how you can calculate the power, and then based on the orientation, the relative orientation of the current and the voltage, you can figure out whether it's producing or consuming power. Thanks for watching. See you in the next video. Hello everybody, thanks for watching. If you found this content helpful, would you please consider liking and subscribing to the channel? That will help other people find it. And if you won't do it for me, will you do it for my cat, Muon? Named after my favorite subatomic particle, by the way. So, she will be very, very upset if you do not like and subscribe. So please, don't disappoint. How could you say no to this cuteness?